who have been experts overseas, and we try to bring them in and share their expertise with us. This is also co-hosted by the Office of Vice Chancellor for Research and Innovation, and also the School of Environmental Science and Management, or SESAM. So what we're having today is actually at the core of the vision mission of the Institute of Computer Science, where we bring in experts from these different fields. It's not only about technology, but it's in the use of technology together with data. No, we will hear more from Attorney Chad. Data and the ethical side of it, using using everything and the technology for the betterment of society. So thank you very much for coming, and we know that it will be a fruitful afternoon for everyone. Thank you, Attorney Chad. Thank you, everyone.
Thank you po, Doc Rachel. So, moving forward, no, hindi na po tayo magpapatumpik-tumpik pa. Today's activity will be split into 5 parts of the workshop proper, excluding the open forum and discussion with our esteemed speaker for this afternoon session. Best believe we have the best of the best on board here in the Physical Sciences building. I have the greatest honor to introduce our well-renowned speaker for today. Attorney Chad Patrick Osorio is a lawyer, applied economist, and a PhD researcher at Wageningen University and Research in the Netherlands, an adjunct assistant professor for the University of the Philippines Los Baños School of Environmental Science and Management. He currently serves as a DOST Picard Balik scientist under the UPLB Office of the Vice Chancellor for Research and Extension. He is the first lawyer in the history of the Balik Scientist Program to receive the award. He is also the first Balik scientist to be hosted by the UPLB Institute of Computer Science in its 44 years of existence. Attorney Osorio's research focuses on wildlife trade, biodiversity governance, artificial intelligence, and sustainability, drawing from interdisciplinary experience spanning psychology, business, law, and economics. He works on developing innovative approaches to understanding and addressing complex social and environmental challenges through evidence based research. Let's welcome him with a big hand, attorney Chad Patrick Osorio.
Thank you very much, Dara. Thank you very much, Dr. Rachel, for that wonderful introduction. Um, so today I will be talking about AI and biodiversity, and I thank everyone here who have come all the way to Los Baños, from the far reaches of Los Baños. Also, we have colleagues from the United Nations, from CITES, and from the World Wildlife Fund in Hong Kong, in the UK, and in in Switzerland. So hi, shout out. Thank you for coming. And so we have here right now a group of people from all over the world, from the Philippines to uh, all over Southeast Asia to Europe and the US. And all of us here are interested in AI for biodiversity. And this is what we're going to talk about today. So you might ask though, um, based from the introduction a while ago, Chad, you're a lawyer. What are you doing in AI? Also, what are you doing in biodiversity? Aren't you a fish out of water? Well, the thing about it is, um, back please. Thank you, thank you. So the thing, let me give you a little bit of background about my life as a person. So I have a degree. One moment. Voila. Okay. So I have a degree in psychology. That was my first degree. And so I focus on criminal psychology. After that I went to law school. So hence the attorney title. But then I realized when I was a lawyer, and I wanted to make policies and laws, it's very difficult to talk to policymakers and politicians without understanding the thing that they love the most, without speaking their language. Can anyone guess what it is? Starts with M. Money. Yes. Congratulations. I'll give you money later. I'm joking. So money. So that's why I took my master's in economics, so that I would be able, as a lawyer, to translate um, policies into something which is understandable to businesses and policymakers, which form a huge part of the policy thrust of what we do. And of course, ever since I've always been an environmentalist. So I used to do a lot of work for the environment, volunteering, etc. So all of these things, they converge into what is my PhD now today, which is the illegal wildlife crime in general. So I am advised by four amazing people. Three of them are from Wageningen University in the Netherlands, and one of them here from the University of the Philippines, Los Baños. And so together with them, I have been spending the last 4 years of my life working on my PhD on wildlife trade. So this is Chad number one. Chad number two, unfortunately, has to earn money. As an environmental lawyer, you don't earn a lot of money. You do a lot of pro bono, you do a lot of volunteering. So, unfortunately, Chad number two's mom will have to tell him that he has to earn. So, on the other hand, I work a lot on business and technology law. So, that's the second part of my life. I work a lot with the World Intellectual Property Organization, for example, on artificial intelligence, which started all the way back in 2017 when I was working with Asian Development Bank and we presented our project in Japan on AI, IoT, etc., etc. So that's my life since 2017. And so what happened now was, with these two things, Chad one, which is the environmental advocate, and Chad number two, which is someone working in the field of AI for many, many years, I realized I wanted to bring these two together. These are not two Chads. These are like, how do you say it? Cara e cruz, right? So one side of me, one side of me. Now you see the full side. And so I asked for the support of the Balik CITES program. I asked for the support of the Institute of Computer Science and the School of Environmental Science and Management, SESAM, under Dean Day, and Doc Rachel, of course, from ICS, and under the general flagship of the UPLB Office of the Vice Chancellor for Research and Extension under Vice Snell. So here we have this project called AI for Biodiversity. So, are you guys ready to have this workshop today with me? Yes. Okay, thank you. I love okay. So now what we're going to do is we're gonna ask like maybe three people. What are your expectations for today? What do you expect to learn for today? Is it okay if I go down? Yes, it's okay. I'm the speaker, so I can do whatever I want. Yes. Do you have any expectations for today?
Learning something new that we can probably apply at ACB.
Okay, learning something new that they can probably apply at the CN Center for Biodiversity. By the way, thank you for coming from the ACB, from the forestry, from the marine sector. Ang dami po. And of course, our students as well. So learning something new. Okay, we're gonna try to do that. How about here?
For me as a statistician, my interest is more on the AI part and also having work in the agriculture sector. So I would like to see the intersection of AI and biodiversity.
Okay, thank you so much. So intersection of AI and biodiversity, also statistics. Can I mention your previous affiliation?
Agriculture Organization of the United Nations.
Yes. So he's also my friend from Rome and France, and now in the Philippines. So we all come back here just to learn from each other. So and then last one maybe from the online. Anyone from the online? Just because you're online doesn't mean you can escape from my question and answer portion. Anyone? Expectations from online? They don't have any expectations. Great. Okay, so learning something new today and also connecting things to different fields. Let's see. How many things did we get from in this round? First one, Okay, by the end of this 2-hour workshop, ideally, we should understand what the purpose and structure of the CITES database. So this is really what we're going to be talking about. The second one is identifying research opportunities using wildlife trade data. So from the CITES database, it's not just that we're going to learn about it. We're going to put on our thinking caps and see what questions can I answer based from the data available with me in this CITES database. Third one, formulate data-driven research questions. And later on, we're going to talk about the importance of why data-driven is super important and why it's good to mix statistics and computer science and economics to policy making. And of course, understand how AI can support data analysis and research workflows. So all of these are hopefully something that we here at ICS in coordination with CESAM, in coordination with OVCRE, will deliver at the end of this workshop. So is that okay with everyone? Can I see thumbs up? Yes, I see people not doing thumbs up. Can I see everyone thumbs up? Yes, thank you so much. Also at the online, yes, okay, yes, I love it. Thank you so much. They're listening. That's nice. Okay. So, on the other hand, you have expectations from me. I also have expectations from you. This is like a love affair, right? It's not only just me doing all the work for your love. You have to do some work for my love as well. And that means my expectations, if it's okay, are that you would proactively participate. You are grouped in smaller groups. You're gonna be hopefully you meet at least one new person today from a different field. And so that you can talk, you can engage, you can learn from each other, hopefully create new projects out of the projects today. So is that okay? Are we going to try to meet someone new today? Give me thumbs up, please. Yes, thank you so much. All right. So now let's go to what we're going to do today. So today we're going to do four things. First, we're going to discuss why wildlife trade data matters. Next, we're going to introduce the Global Wildlife Trade Database. And then from that database where we have raw data, we're going to talk about the research questions. So what if we have data? I mean, you give me a pile of numbers and I don't know what to do with it, right? You have to enable ourselves to structure that data into actual research questions that we can use for policy, for science, for the things that we want to do in order to support biodiversity. And lastly, let's go to what a lot of people are here today for, using AI to analyze wildlife trade data. So I know that there are some people from the UK, from the US, from Geneva and Hong Kong who are here, well, not here physically, but online, and they might want to skip parts 1 to 3 because they already work deeply with wildlife trade data. But what they're here for actually is they're interested in using AI to analyze wildlife trade data. And this is also the strength of this workshop by bringing together the expertise among you. Are also people from ICS. You have to figure out which ones are from ICS. That's the game today. I'm joking, but all of the idea is that we can work together in order to use AI to do something different, to do something new with what we already know, with what already is available. Okay. So, first part, why wildlife trade data matters. First of all, what is wildlife trade? Wildlife trade is all about sales and exchange of wild animals and plant resources by people. Well, it can also include fungi, but and the general thing is we think about wildlife trade as only animals, but it actually can also include plants under this definition. Wildlife trade is generally legal, which means that you can bring um, plants or animals to somewhere else, depending on the laws and rules. It only becomes illegal when it's done in contravention to the law, meaning it's banned and you decide to bring it abroad, or it's done in contravention to the limits set by law, meaning you're only allowed to export 100 species, 100 specimens of a specific species, but you export, say, 105 or 110. So, why does wildlife trade matter? so what? Like, why do I care about wildlife trade? I don't have any tigers for pets. Does anyone have a tiger here for a pet? No, no crazy rich Asian here. Unfortunately, I'm so sorry, everyone. Not yet, not yet. But also, why? Why, right? So, why does wildlife trade matter? Anyone? From the, I don't want to call organization names, right? Okay, so I'll try to answer it based from my perspective. So wildlife trade is a huge threat to biodiversity, which means it can harm the environment. It can harm biodiversity. 950 plus species are at risk because of high international demand. At the same time, 65.8% face reduced abundance in their native population because of international trade. Now, again, we mentioned wildlife trade is both legal and illegal wildlife trade threatens one third of all the birds and mammals in the world. So that's the ecological part of why wildlife trade matters, why we should look at wildlife trade. But wait, there's more. If you look at wildlife trade, poorly regulated wildlife trade can facilitate invasive species. So it's not just from the home country, from the source country, you also can harm the destination country of these species. So they can become invasive, harming the ecosystem of the country where they were brought to. It has a cascading effect on ecosystem services and reliant industries. What reliant industries are these? Agriculture, forestry, aquaculture, basically food producing regions in the world can be harmed because of invasive species, can be harmed also because you're taking something and putting it where it does not necessarily belong. And also pharmaceuticals, etc. It can also increase the risk of zoonotic diseases. So you see from the environmental harm, ecological harm, it now translates to harm for humans and other animals as well. So zoonotic diseases, COVID, and also the rise of epidemics. At the same time, when it becomes illegal, it's not a standalone crime. It's the fourth largest criminal activity in the world, next to drug trafficking, human trafficking, and weapon smuggling. So that means it's huge. It has billions and billions of dollars in damages worldwide, in valuation worldwide. And also it affects developing countries disproportionately. That means poorer countries like us, the Philippines. I mean, monetarily poor country because we know we're rich. Poorer countries are affected disproportionately, especially on communities, indigenous population who are depending on natural capital. They give they give the harvested species to someone else who makes a lot of money for them, but they only get a pittance. So that's a problem. Those are really, really bad problems to have. So what you can see is that wildlife trade is crucial because it affects not only the environment, so it's not just out there, but it's also near us. It can potentially impact our daily lives. So now the question is, okay, sure, Chad, you've convinced me. Wildlife trade matters. It is important on so many different levels. But why does wildlife trade data matter? Why should I look at wildlife trade data? Why should I make my thesis out of wildlife trade data? Why should I study this thing? It's so many. Well, let me tell you about the Cobra effect. Does anyone know about the Cobra effect? Okay. So some time ago, India was overrun by cobras. There were so many cobras, and then they decided that the colonial British Empire decided that uh we're gonna pay you for every cobra head that you bring to us. You can imagine what happened next. So what happened was people, enterprising people, they started breeding cobras. And then they cut off the heads and then gave it to the administrators so that they get paid. Then the administrators were like, how come the projected number of cobras is a lot less than the number of cobra heads being brought to us? So that what happened now is an incentive which was created because of the money of the monetary policy given for the cobras. So this is an example of unintended effect. And what happened? So they said, okay, let's stop this incentive system. And so the Indians, they were so angry because they were breeding cobras. They spent money, time, effort um, on this. And then they said they're not going to pay anymore. They released the cobras into the wild. And so they have more cobras now at the end of that period rather than when they started because of the policy. And the policy was not because the policy was not properly thought of, not properly designed. And so this is why wildlife trade data is crucial. We need to understand, to regulate and conserve biodiversity using evidence in an increase, especially now because we have an increasingly globalized wildlife market. So this is something that I'm working on with three of my advisors, Dr. Abatayo, Dr. Richter, and Dr. Bernas, on the unintended consequences of wildlife trade bans. What we want to do is ideally use wildlife trade data so that our policies will not result to things like the Cobra effect. So wildlife trade data matters in so many different ways. It can be used to track conservation threats and detect emerging trends. Later on, we're going to show you how we can do that. We can use it to identify trade networks and also potential hotspots, and also which species are being traded the most. And then we can also monitor monitor compliance with domestic and international regulations. I'll show you this, assess policy effectiveness, whether it works or it doesn't work, support evidence-based policymaking, and lastly, prevent unintended consequences. So all of these are very much important in in creating the evidence to make sure that wildlife trade policy does not create unintended consequences and become even more harmful than what it sought to prevent. Are you still okay? Okay, great. I'm just getting started. I'm just getting riled up. So now, I only have two hands. So now let's talk about um, wildlife trade data. So, Chad, okay, great. Wildlife trade data is amazing. It's interesting. Where the heck do we get that? The thing is, people have been worried about the illegal wildlife trade and also the over harvesting of wildlife trade since 19 kopong kopong. So, in 1972, they actually signed an agreement to monitor and get data on wildlife trade from all over the world. And this is where we show the Global Wildlife Trade Database. We're talking about CITES, the Convention on International Trade in Endangered Species of Wild Fauna and Flora. So it's known as the Washington Convention because it was signed in, yes, Washington. Very good. CITES was originally signed by 21 parties in 1973 and entered into force in 1975, meaning that they agreed in 1973 and then it only starts in 1975. As of January 2023, though, it's composed of 183. So from 21 to 183 state parties in the European Union. It's regarded as the most important and best supported instrument for wildlife trade. Why? Because it has so much data, which I will get to. So it seeks to protect an estimated 6,600 animal species, and 34,000 plant species in its three appendices. So it's reviewed every actually in the law it says 2 years, but then what happens is that it gets reviewed every 3 years. So how it works is this. I have, excuse me, I am a country, I am concerned for my species or the species of my neighbors or the species of something of another country, and then I will put it into proposal that this particular species should be protected. And so CITES will now vote whether it will be included in the monitoring and quota system or not. And So it's under 3 appendices. So if you are a species and you get listed into the CITES database, you're under 3 potential appendices. First one would be bans. So if you're in Appendix 1, you're banned from being commercially traded. You can be traded for that species can be traded for zoos, for example, or for scientific purposes, but you cannot be traded because you want to sell it in a local pet shop. On the other hand, you have Appendix 2. Appendix 2 are those which are traded on a very limited scale. So these are the quota systems. So you have, say, 400 specimens of these species which are allowed to be traded. And then Appendix 3 contains species that are protected in at least one country, and that country is asking for support from the entire CITES community to help protect it. So for example, a ban for elephants. Elephants might not be the good example because it's split listed. So a ban for a specific species, for example, normally applies to the whole world if it's coming from if it's under Appendix 1. But if it's under Appendix 3, if for example I have a species from the Philippines, I will ask the whole world to put it in Appendix 3, and the whole world will help me ensure that the species from the Philippines, like a lemur, will not be traded from the Philippines but other countries from their own but if it's sourced from other countries, then it can be freely traded. So that's the difference between Appendix 1, Appendix 2, and Appendix 3. So the appendices of CITES have 2 functions: regulations and bans. So regulation meaning that we limit the number of species, specimens, kilograms, etc. that were traded, and bans would be absolute stop. Nada, no, hindi, bawal. So it also monitors the trade of species. So if you are a species listed in CITES, every time you go out of a country or into a country, then you have to be logged in. So it's like an ID system. And the CITES, since it has data from 1975 to present, it maintains the world's largest database on wildlife trade, particularly on CITES listed species. So it has around, I think, 25 million transaction records. So if you are a data scientist, for example, and someone tells you, I have 25 million transaction records, that's music to my ears, right? Because you have a lot of data to work with. You can do a lot of data manipulation. You can basically use it for so many different things. So that's the CITES database. 1 million new entries added annually. What is in the CITES database? So the CITES database has several different things. It includes the species, um, which includes taxonomic data, which is basically family, genus, species, etc., etc. So you can do a class level analysis or a family level analysis. It has importing and exporting countries. So who imported this and who exported this? Also, if it has been re-exported. So for example, it came from the Philippines and went to Italy, and then it went to the US. So you can see that the Philippines will be the origin country. Year of trade. Term of trade meaning how was it exported? Was it live specimens, meaning like a whole animal or plant? Or is it leather? Is it already a bag? Is it already a wallet? Or is it a skin? So together with the unit traded, how was it exported? Is it kilograms, grams? Is it meters, etc.? um Quantity traded, how many of that was traded? Source of specimens, where did they get it? Did they get it from the wild? Did they catch it and then captive bred it, or is it artificially propagated, etc., etc.? And what is the purpose of the trade? Is it commercial? Is it for zoos? Is it for scientific purposes, etc.? So it's a treasure trove of data. And so you can actually see, okay, where do we get those species, etc.? Do we get it primarily from the wild, or do we get it farmed? When was the year where the most trade was recorded, all of these things. So now let's move on to exploring the CITES database, the case for live marine species. I am very much aware that I am telling you a lot of words. And since this is a workshop, I want to not only tell you, but also show you. But before that, can I get a thumbs up from everyone? And then the other thumbs up, please. Other thumbs up. Please. Thank you. Yeah. I just want to make sure that you're not asleep. Because when I was a student, I also liked attending conferences. And I also like sleeping because it was aircon. So I am afraid of my own ghost. So now I want to ensure that everyone here is listening to me actively. Otherwise, you will not get snacks. That does not apply to our friends from the online section. Yes. So now let's talk about exploring the CITES database. Okay, so see here, we wanted to look at live marine trade exports. So meaning we took a subset of all the species which are marine, and then we took another subset of all the species which are live, meaning that they are still alive when they were transferred from one country to the next. So you see here, the first one is the number of transactions per year, and the second one looks at the transaction volume. The difference is that one transaction can have multiple live specimens. So for example, one transaction can have 10, one box can have 10 species. So that's why normally, so you see here, it's only 150,000 transactions, 100, probably 110,000 maximum. But here you see the live marine species, if you look at volume, it reaches up to 400,000. You can also look at the top traded live marine taxa by trade volume. So you see a lot of the live marine taxa are corals, with the exception of Tridacna, the Tridacna croquea and the Tridacna maxima, which are giant clams. So you can see from all over the world that this is the most traded live marine species. We can also compare different exporters. So for example, we can compare which one exports uh species by number of transaction versus which one exports by volume. Why is this important? Because you can also see how many traders can be active. For example, Indonesia is similar across both numbers, but then Fiji has more transactions, but relatively lower volume compared to the Australia has more transactions but lower volume compared to Fiji. So for example, Fiji only has 79,000 transactions, but then it has 19 million um, species traded. So meaning each transaction would have a lot more species traded compared to Australia. We can also look at the source of live marine species, which means that we can see of all of these of the live species traded, how many are wild caught, meaning we got it from the wild? How many are bred in captivity? How many we don't know? They didn't declare, but they still allowed to transport it. So all of these are different ways by which we can explore the live marine species. You guys still good? Okay. I know that this is a lot and I totally understand. I can upload the PowerPoint. No, I can send the PowerPoint in case people ask me about it. Please message me so that you can also study it and learn from it. And again, feel free to connect with me, with CESAM, with ICS, with OVCRE, if you want to work on these things further, or if you want to learn a little bit more about it. We don't want to overwhelm you with everything that I've been working on the last 4 years, and also it's gonna be too much for everyone. So this is only a taster. Kumbaga, in Filipino, patikim pa lang po yan. So what we're going to do now is we're going to now look at raw data to research questions. So at the end of the day, I can give you all of these information. right now, it can be overwhelming. Okay, can everyone please close your eyes? Please close your eyes. I can see you if you don't close your eyes. Okay. Um, and please be honest, okay? Close your eyes, please. Thank you. Okay. Who here is a little bit overwhelmed with the too much information so far? Raise your hand. Don't be shy. It's fine. Okay, put down your hands. Okay, open your eyes. Okay. So for some people at this point, it can already be too much. So that's why what we want to do now is move away from the barrage of data, and we're going to move into something that is easily understandable, especially to people who might not be very well versed in handling data, in handling a lot of information, especially quantitative information. And that's okay. This is the reason why we're doing this. So we're going to transform all of this into research questions. So the question now is, what is so what studies have used this raw data in order to answer specific research questions? Meaning, how has this data or how has this database been used in order to translate to something which is applicable in the real world? So for one, we have global trade analysis. You can use CITES database to look at all the CITES listed wildlife, looking at patterns and trends in just 40 years. So this was published in Biological Conservation. Or you can look at also the challenges, because it's not easy working with such a huge data set. So it's important that we also acknowledge the challenges when we do this. We can also do regional analysis. This is particularly useful for ASEAN, for example, or the EU, or et cetera, et cetera. So there are studies about it. So for example, Southeast Asia, they looked at international legal cooperation, which involves CITES data, and also Southern Africa. There are many more. We have EU, wildlife bird trade, you had Middle East. These are just a sampling of the kind of analysis that we can do with CITES trade data. We can also do analysis of specific markets. So for example, caviar, we can look at the luxury market, or we can look at, for example, the pet trade, the exotic pet trade, like frogs or snakes or whatever. We can look at country-specific studies. Thailand, for example, and its performance in CITES, or the Philippines. We can do per country analysis. So if you're interested in a specific country and they are a signatory to CITES, then you can have or a signatory to CITES or someone who gets trade from a signatory to CITES, then you can have information on these country-specific studies. We can also look at taxon. So for example, for marine species, which I was doing a while ago, we can look, for example, just at marine species, or we can go even further and look at seahorses or live clams. We can also look at forest species like plants or timber, etc., etc. So here we have specific examples. Wild mammal trade driven by species ecology. So mammals, and also raptors, like birds of prey, and then also amphibians. So it can be by taxonomic classification. You can do analysis of that. Impact assessment would be assessing the impact of international trade on CITES listed species, whether it has been listed in Appendix 2 or not, and whether it actually impacted the population of the species. There are, this is one, 2011, there's one, I think 2023 also, which looks at that. And also, if CITES trade restrictions work, so it's policy assessment and whether it actually works or not. Of course, you don't have to be limited to just one data set. As with a lot of these other studies they also use the CITES trade dataset in conjunction with an existing other dataset like agriculture datasets, or even what shall I call this? Or even satellite data, or biodiversity data, etc., etc. So epidemiology and how fast diseases spread. So there's a lot of different ways by which we can use the CITES data set in order to identify not only direct impacts of the wildlife trait, but also indirect impacts. Hence, we use other data sets. And so that's why we, for example, find unintended consequences of wildlife trade bans. So overall, we have one database, but we have many different research questions. From the environmental sciences, we have, okay, which species are most vulnerable to trade? Or for example, for economics, for policy, etc., etc., computer science, criminology even, there's so many different research questions that we can ask. And we can attempt to ask using the CITES trade data set together with together with other data sets. Now the question is the CITES database perfect? Who says yes? Or maybe close your eyes so that everyone people are not uh shy. Okay, who says yes, the CITES trade data set is perfect? Sana all perfect, right? Okay, who says no? The tries. Okay. Yes. Okay. Thank you. Okay. Put your hands down. Okay. Open your eyes. Okay. I think everyone is in agreement, and that the CITES trade data set is not the database is not perfect. Also, in our online people, they also close their eyes. They should also close their eyes. They're not gonna get certificates of participation if you don't close your eyes. Okay, so CITES database is not perfect. There's still a lot of potential hurdles. So there are actually a number of caveats. Remember that it was started in 1975, the database. You have species listing changing over time. You have differences in the level of enforcement per country. Not all countries have this as their priority. So you have a lot of weird stuff going on. So for example, not all trade is captured. This is a snapshot of the world in of the world who in wildlife trade data at a specific year, but only of countries who are signatories or trade partners of people who are of states which are signatories. So it's not all countries. Also, it's not all species. It's only CITES listed species. So only endangered species are captured. So ordinary species like the clownfish, they're not necessarily captured. They're not their trade is not monitored in the CITES species. Highly active internal domestic market. The CITES is also looking at international trade. So not necessarily domestic trade. So even if the international market gets cut off, species can also be decimated because at the end of the day, you can also have a highly active internal domestic trade. And also, not all countries, as pointed out by Doc Arvs the other day, not all countries actively participate. Some of them are late when it comes to their monitoring requirements. They have challenges in how they monitor it. Even the standards of monitoring are different. Instead of putting the actual trade, they put in the trade permits, etc., etc., etc. So it's not perfect. Importer and exporter reports may differ. Why is that so? Especially for live species. Can anyone guess why? Starts with a D. Species may die during transport, right? So for example, I reported 100 pangolins. Well, pangolins are not allowed to be. So something which is traded, I report 100 species, and then the importer reports 50 species. It could be a number of reasons. Maybe they miscounted, maybe etc. etc. But one of the things is also that they can also die. Also, one country is different from the other when it comes to their standards of reporting. So you can have different ways by which you can actually measure it. And these countries might have different ways by which they do measure it. So one country, for example, I'm the exporter. I say 100 kilograms of a species was transported, but then when it came to the receiving country, they measured the number of the weight of no, the number of logs, for example. So that's also a problem. Missing or incomplete information as well. Um, and then quantity measures are not always comparable. Again, what I mentioned a while ago. Temporal permit lag, meaning, for example, because it's yearly data. So sometimes I would send it by December, but then it would arrive in January. So what happens now is it will have two listings. So it could result to double counting, which we have to check because that's why it's important to also look at the trading number. Changes in taxonomy over time. Some species um, they change taxonomy, meaning they're classified under one family and then they get moved to another family over time. So that's also a problem, a possible thing. Also, countries change. Some countries which were before, for example, the Soviet Union is not a country anymore right now. So that means that you also have to account for these little changes. Not actually little, they're big. And then trade volume is not equal to conservation impact. The fact that there's a little like trade volume has decreased does not necessarily mean that conservation is achieved. What like maybe trade volume has gone down because these people cannot harvest anymore. So it actually points not to a good thing, but actually a bad thing. So legal trade also does not equal sustainable trade. When it comes to we say okay, the limit is 100, but we actually don't know that. We actually are trying to guesstimate. Okay, this is the sustainable trade, but it's a flip. It's a coin in the air. So in correlation, so many things. I could go on, but we're gonna be. I only have uh around 30 more minutes to go. So I want to focus on the AI part and not necessarily the caveat. But what I want to show here is that at the end of the day, CITES, just like you, just like me, it's not perfect, right? It can be improved, but it's the best possible evidence right now that we can. And since it's the best possible evidence, maybe we can use it sparingly, warily, with all the assumptions being transparent to our readers, to our policymakers, to the people we're making this for. And so what we want to do is ideally we look at the CITES database, we look at what information it has, and then we can think of how do we use that in order to support a species, support a particular country, support general biodiversity in some, etc., etc. Okay, so this we will have an activity. Is that okay with you? Can I get a thumbs up, please? All right, thank you. Okay, so now the activity is this. So you're grouped into smaller groups of 5. Yes? Hopefully you're together with people you don't normally work with. If not, then I'm sad. Don't make me sad, please. It's good to get to know people from different perspectives, different fields, etc. Okay. So anyway, we're going to take maybe a few minutes of your time to go in a group and think about a specific research question related to CITES trade data. From what we've have in from what we've discussed so far, from what the information I gave from the information that I gave, what interesting thing can you think of? So this is an individual assignment, but I want you to discuss within your group as well. So is that okay? So please form little circles if you can. Also, this works also for our online participants. So please take a few minutes think about, okay, what am I interested in? Like, what am I gonna use the CITES data for if ever I have to use the CITES database? What am I curious about? What could possibly be related to trade? Okay, I will be going around and then asking different groups different questions. Yeah, and also take the chance to get to know each other. Okay, see you in a few minutes. Check. Okay. Okay. So everyone, I hope you've been enjoying your discussion with the groups. The goal for this first activity is not to write a research paper, okay? Not yet. I've already heard people saying, "Oh, let's have a project together. Let's use my LGU as a pilot place." All of these things. So I'm super happy about this. But wait, there's more. If you can order, no, within the next 5 minutes, I am joking. But okay, so now can I have everyone's attention, please? So everyone, you can face me now. Yes. So I hope you were able to list down ideas, or if you don't have any ideas listed down, at least it sparked your curiosity. It enabled you to meet new people and maybe hopefully see how we can explore different things. Okay. How about our people from the land of online? Okay. We also have a lot of different ideas. Okay. So from online, we have what conservation risks are associated with cultural consumption of CITES listed species in Samar Island. Okay, so that's pretty good. I actually have an upcoming paper on culture and conservation, so that might be useful. Association between international trade and IUCN. Actually, that's also been people have been trying to answer that, and it would be interesting. So trends in international trade volumes of plant species and which require priority germplasm conservation. Okay, that's also something I will defer to the germplasm experts here, but I think it would be interesting. So yeah, there are so many different ways by which we can use the CITES database um, to understand the world around us and biodiversity conversation and biodiversity conservation. Okie dokie. So now let's move on to basically how do we now use AI? So a lot of people online also here they're familiar with CITES database. A lot of you it's your first time, so it's good that we've more or less acclimated to the CITES database and how we can use it to answer research questions. Now let's take it one step further. How do we use AI to understand and analyze trade data? So what I'm going to do is I'm going to breeze through AI and the different applications of AI, different use cases of AI. I'm not going to give you a lowdown of everything AI related because that will take maybe until tomorrow and I might not even be finished yet. So we're just going to breeze through different use cases which can be potentially useful for us. And what I'm going to do is showcase 3 research projects with 2 ICS instructors and assistant professors, well, 1 instructor and 1 assistant professor, to highlight how we've been using different use cases, different modes of AI to answer specific research questions. So AI, as you would know, is something that is a buzzword right now. Everything is AI. Even I don't know, shoe selection is AI. Netflix is AI, recommendatory systems. Chat GPT, Claude, etc. Those are LLMs. Different means and ways by which you use AI. It basically deals with intelligent systems, which can help us make sense of a lot of different data. And it can ideally reason, learn, and act autonomously. Now, pop, 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 pop. Voila. Okay. So there are different ways by which AIs are used. By which AI is used. So you have recommendation systems, you have predictive analytics, etc. What we were talking about a while ago is fraud detection, anomaly detection. On the other hand, you have NLP, Doc Rachel's expertise. You have chatbots and text processing, speech recognition, language transition. There's so many different ways by which we can use by which we can use artificial intelligence, it basically allows us to parse and put a lot of data together in order for it to learn and understand different things and to do different things, like image generation, for example, like what took the world by storm, like Nano Banana, and even what they call Mid Journey. I think that was like the first popular image generation app out in the market. So there's so many things that we can use to do for AI, and because of that, it's applied to so many different fields. So, for example, in healthcare, they use it for radiology, so that they could see whether a person would have, say, um, uh, a form of cancer, or they would check, for example, for specific things, drug discovery. Also, you have finance, you have retail, etc. I can go on and on. But the thing that I want to highlight is that when you say AI, it's not just like one thing. It's not just like chat gpt saying things, random things. There's so many different ways by which we can use different which we can use AI in application to different industries. So now the question is, we're here because we're interested in biodiversity. We're here because we are aware of the CITES wildlife trade data. Now, how can we use uh, AI in order to process this data to make it more understandable, to make it more applicable to how we use, to how we implement policies, to how we control and moderate trade, to how we promote culture, for example, in order to enable people or discourage people from engaging in wildlife trade. So AI, in particular the CITES database, can be used for several things. So it can be used for machine learning, and deep learning, for example, can be used to forecast wildlife trade trends. So you have a data set, and then you give it to your model, and then the model learns it, and then from that, from the data that it has been given, it can forecast future trends. So it can ideally decide what the next demand will be, or for example, what species could be on the next list of endangered species based on trade alone. It can also detect anomalous or suspicious trade patterns. So it can cluster different um, species and then identify per variable, and then identify which one does not belong to this particular group, for example. We can identify species prone to vulnerable trade. Again, also related to forecasting, visualizing CITES listings on trade dynamics, both as a function of forecasting, but also just historical data itself. Predict trade networks. So it's not just about predicting which countries, it's not just about predicting which species. We can also predict trade flows, meaning which countries are likelier to have more imports or exports based on historical data. And of course, automating species and trade intelligence. These are some of the many ways that we can use AI. As we can see, because AI is so broad, we have so many different applications of it, that we can use all of these things and more to apply to the CITES database. So, Chad, why are you using AI? Why not just use traditional statistics, traditional econometrics, naive methods is what they call it, in order to answer your data set, or in order to answer your research question? Well, the thing is, I'm human, and a lot of us are human, and it will take me quite a lot of time to go through the 25 million data points, the 25 million observation, whereas, for example, AI can handle that relatively easier compared to how I can do it. For example, anomaly detection, it would be easier for the machine learning to identify anomalous transactions compared to me having to check each and every one of all of these transactions. So there's a number of different reasons why AI, machine learning, and deep learning is preferable. But as we see later after um, my demonstration, sometimes it also is better, or it also is good to compare these methods side by side, because sometimes naive could be better depending on what your models show. Okay, so let's first look at one of the projects that we're working on. It's data forecasting based on Philippine trade of CITES species. And I forgot to animate the note from Iram. It's supposed to come later on. But in any case, pop, pop, pop. Okay. So now we have this. Sorry. How do I transfer this? One moment. Sorry, can I ask for someone to move one of the screens here? Uh, ito. Is it? Yes, thank you. Thank you. Okay. So for example, in this screen, we see so what we did was we took all the wildlife trade data from the Philippines, meaning to the Philippines from the Philippines, and we put them in a subset. And then what we did was we wanted to see whether we could forecast the trade in species of based from this particular data subset. So what we first did, well, what Iram particularly did was he compared four different models. So he did the naive model, which does not use which does not use AI, which uses and then he did the LGBM, which uses machine learning. He did Chronos, which uses foundation models, and he used DeepR, which is more deep learning. So these are different types of complexity and different models of AI. So ideally, what is important here is that when it comes to forecasting, you want to look at uh, the trend which has the which has the lowest error, So, for example, as you can see here, it's the LGBM, which uses machine learning, which has the lowest error as compared to, for example, this is the naive model, so the error is relatively high compared to LGBM. So that means that it's a lot better to trust the LGBM, the machine learning model, compared to the naive model, compared to, for example, the Chronos model and the DeepR model. So what that means is that we can use, now that we've understood where the which ones have the higher errors, or which ones have the lower errors, we can now see um, at which forecast we can look at um, to understand reliably where the trade will be. So for example, this one, so this is the LGBM using the machine learning model. Um, from here to here, we can see that it increases around 2025 to 20, this is 2030. Yes. 2025 to 2030. So, this is an example of how we can use number one, wildlife trade data to forecast future exports to other countries. But at the same time, you also see how different models using machine learning or deep learning or foundation models can vary significantly, or not even vary at all. It really depends on how we train them and how we use them in order to see how we can forecast data and which models we can choose. So this is one. So, note from Iram, the more complex the model doesn't mean it's better. So, that's one of the things that we're looking at when it comes to forecasting. So this is a work in progress, and we're also going to look at other parts of probably ASEAN in general, because with the bigger the area, you'll have more data. So maybe we'll also see a difference in which model to use, for example, or how accurate the model, the forecasts can be. And then let's look at, again with IRAM, global trade of live marine species. So live marine fishes. So we took out corals, we took out clams, we looked at fishes, like primarily actually for the aquarium trade. And then we wanted to see whether whether there are anomalous transactions. And let us check. So that, that, that. Okie dokie. Other side, yes. Okay. So live marine fish. So what we see here is that, for example, um, uh, it grouped all the attributes together of specific countries and specific trades. And one thing which is interesting is that Vietnam reports a lot of wild, a lot of captive species, when in fact, compared to all the other reports from other countries which have similar attributes or relatively similar attributes, they should be um, they should have been classified as wild caught instead of farmed. So what we see here now is basically Vietnam having a really high um, chances, well, really high anomaly or level of anomaly, which means that it's ripe to investigate. So again, it does not necessarily mean that Vietnam is already doing something illegal, but then at least we have a lead up into how we can investigate this trade data. And this is something I want to highlight as well. So a lot of these uh, machine learning, deep learning, AI applications in general would still need the input of bio experts, ecosystem experts, legal experts, in order to make it understandable, in order to make it work. At the same time, it's difficult also for us as individuals to handle a lot of these huge data sets. It's nice to have some support from computer scientists, economists, data scientists, in order to make sense of all of the data, because otherwise it will not be used. Our last example is the giant lab clams. So this one, I'm working with Dr. Zinit Arnejo, who unfortunately is not here with us today because she's at the French embassy, to which I am also invited to. But unfortunately, well, fortunately, I chose to be here with you. So I hope that makes you happy, because it makes me happy to be here with all of you guys. Oh, that's a cute say. Oh, I'm joking. I'm joking. But so what we looked at for our project is the global trade of giant clams. And so Dr. Ernejo specializes in agent-based modeling. So agent-based modeling basically um, assigns countries and species as models, as agents, and let them play it out. What happens is that they basically get the parameters of their behavior from uh, data, from historical data, and then afterwards we can now, for example, well, first we can model um, historical behavior, but then afterwards we can also forecast future behavior based on the parameters that were set during the training from the historical data. So this is trade exports of live giant clams. So this is what the data set that I gave DocCNet. And then so DocCNet created this system on how the agents will work. So the agents will basically have all of these different factors in their behavior. And so based on these factors and based on a number of considerations, that will now define how the models will act, how the agents will act in the future. So this is just a sample of the output of agent-based modeling, agent simulation. And again, this is a work in progress. There's still a lot of things to be done. Um, basically what we're doing here is we're seeing three different things, three different scenarios. In the first scenario, whether business as usual, the second scenario is if we increase enforcement, do we actually see lower trade? And then the next one is what if we look at different factors like culture or other different how do you say it, levers that we can push for human behavior, then maybe it could also be different. So that's agent-based modeling, and we can apply pop, pop, pop. How do I exit and show? Oh no, I don't want to end the show. Wait, sorry. Yes. One more transition, slideshow from okay, from current slide. Okay. And so now, tap, tap, tap. And so now, how do you make it AI? Well, because ABM, agent-based modeling, is not necessarily AI. How do you make it AI? Well, we make it learning agent-based modeling, LABM. Not LBM, it's LABM. And basically, you just make sure that they learn from each other, the agents, so that their decisions are guided by incentives. So it's an entire process. And next time, actually, if you want, if there's also demand for it, maybe we can ask Sir Iram and Doc Sinit to give specific lectures on how we develop these concepts, on how we're working together, what kind of things are required from biologists or economists, what kind of data, what kind of insights. And so what they can also offer, at least from the perspective of ICS and computer science and AI in general. Okay, so I only have how many more minutes? 5 minutes. Okay, so things to remember. Well, as much as we would like to do a lot of these things through AI is not the end all and be all of how we do things. So results are only as reliable as the underlying data and assumptions. What does that mean? Well, first of all, we have to learn and understand the data. We have to master the data, because otherwise, if you just put the data in and we cannot interpret it, that does not make any sense at all. So this is also why it's important to verify, you fact check, and treat AI as an assistant, so not as a substitute for expert judgment. And of course, the best thing to do here is, of course, is collaborate. So the reason why I'm here as a Balik scientist is not only just to highlight my expertise, but also to learn from the expertise of others. So for example, I have never tried agent-based modeling in my entire life before meeting Doc Zenit, but now we're working on this project together. And so it's very interesting that I'm learning from her, but that she's also learning from me. So collaborating is very, very much important, because we need the expertise of people who are well versed in marine sciences or biology or ecology or law, etc., etc., statistics, and then pop, 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 and then also, academic integrity. If you're using AI, especially for those using ChatGPT, for example, to write their freaking papers, which should not be the case, but okay, use AI transparently and also in accordance with institutional policies. So, responsibility, again, if it's wrong, it should be on you. You should not blame AI for anything, especially for those using LLMs. And at the end of the day, what we want to do is you have to be responsible for AI use. You have to um, be aware of how also the ecological impact of AI. So AI is very useful, but at the end of the day, we have to be responsible with how we use it, and we also have to be accountable for the output that AI does. It's only a tool, like what Sinaida Seva says, ang AI, like mga bituin, ay gabay lamang. So, hindi siya nagdidikta ng ating future. So, it's like the stars. They only guide, but it will not dictate, it should not dictate our future. Okay, how many minutes do I have, Iram? Last 15 minutes. Okay. So now, I want you to please group yourselves again into your own groups, or for the online. Um, and then for the online, 5 minutes. Um, identify some AI use cases to support it. So, like what was mentioned a while ago, be as wildly creative. So, for example, to answer your question, would you like drones with computer vision? Would you like I don't know. The sky is the limit. Think about your research question. Think about potential autonomous technologies that can be used to answer that research question. Be as crazy as you want. This is a more creative thing than ever. And later on, I'll explain to you why. Okay, so 5 minutes. Okay. Thank you very much. Can I ask your everyone's attention now here, please? I know it's really short, and I hope you've had the taste of what it is to discuss about wildlife trade in AI. Okay, so can I ask everyone to face me now? So what we're going to do is so we don't have a lot of time anymore, but what we're going to do is we're going to yes. Okay. So what we're going to do is we're going to compile all of these ideas. And we'd actually like to share, and we are grateful for um, uh, the World Wildlife Fund in Hong Kong, Mr. Brian Gonzalez, who is joining us from Hong Kong, and also uh, Ms. Thea Carroll from Geneva, from the CITES Secretariat, who is also joining online. So what we can do is we can also share all of these ideas with them so that our discussions today are not just here with us, but also reaching as far as the different countries that are attending this seminar, this workshop. At the same time, also hopefully we can get feedback from them and continue the conversation regarding AI and biodiversity conservation. So now, at the end of the day, we had four objectives. Unfortunately, as we say, goodbyes will always come. And I hope that even with this goodbye, though, we were able to meet the four objectives that we had today. First, to understand the structure and purpose of the CITES database. I hope we were able to do that. Can I give a thumbs up if we were able to do that? Okay. And second, were you able to identify research opportunities using wildlife trade data? Can you give a thumbs up if yes? If not, it's okay. Um, Formulate data-driven research questions. Thumbs up if yes. If not, it's okay. And then lastly, I understand how AI can support data analysis and research workflow. Thumbs up if yes. If not sure, that's still okay. But it would be really, really great if we were able to meet at least, if not all, at least some of the objectives that we have for this workshop. Considering that we only have it for 2 hours, we are a multidisciplinary crowd. We come from as young as students, university students, to as experienced as people working in wildlife trade from all over the world. So that I think is the good thing about it. We are talking about wildlife trade, we are talking about data, we are talking about AI. So at the end of the day, if we have to think about something that we got from the lectures, from the workshop today, I hope you will remember these few things. Well, first, wildlife trade data is essential. If we want to create data-driven policies and prevent unintended consequences, aka the Cobra effect, then we have to understand wildlife trade data. But second, we can also use AI in order to support wildlife trade data gathering, analysis, and also forecasting. So from before, during, after getting the data, imagining the data, how it could look like, then we can use AI using those CITES global trade database for this. The thing is also AI coupled with wildlife trade data, it's not perfect. There are still challenges with the data set, challenges in understanding and applying it. Same goes for AI. It's not infallible. But what's important is that AIU should be responsible and ethical. And at the end of the day, what is important is that we take lessons. I think something which I take lesson from my Balik scientist stint here is that we have to work together with different people, from with the Institute of Computer Science, now with the School of Environmental Science and Management, with the OVCRE, all to the ACB and forestry and marine people, all to from the lowest to the highest, from levels of governance, from research, academia. What's important is that we learn from each other. So at the end of the day, what we want to show is that AI for biodiversity is really that. It's not just about using one technology or one database. It's all about working together in order to fight for and conserve biodiversity. Thank you very much. Yes. Okay.
Thank you po, Kuya Chad, Attorney Chad, for a very insightful discussion this afternoon. So medyo nag-enjoy po tayo and we are currently over time for our set 1 to 3 p.m. Discussion this afternoon. However, with informative sessions such as this, so we will just be holding a very, very short open forum to discuss our curiosities in the open. So at this juncture, may we ask the participant present here in the EAA hall if they have any questions that they would like to personally ask this afternoon. So if you have questions po, you may raise your hand so Attorney Chad can address your question.
Thank you. So, nakuha ko naman yung intersection between biodiversity and so siguro outside, I don't know, maybe outside of this already. Pero I think para mas maging effective in isang pinaka-importante step nabanggit mo na rin kasi nakita ko yung sites ang haba ng list. Diba? So, isang I think number two. And I think some of those solution something that really yun for sa standardization ng information data. For example, when you talk about geographical standardization, we understand that countries differ across years, but you can look at the geographical data. I mean, Russia was this big information population. So, some and really limit assumptions and so
Yeah, thank you very much, Joe. I 100% agree with you. So Joe and I, we have a lot of discussions regarding data, like years na, no? Years and years back. So Joe has a lot of experience working in the US and in Rome and everywhere. So really, what he says is really true. We really have to also work on improving data management, data gathering, etc., in order for us to derive better insights from using AI. I think we have a last question either from online or in person, and then all the other questions we can route through we can route online. When you can send me an email or send ICS an email in order to continue the conversation. So last question.
Maybe we can ask if there's question po on the other side of the room. Baka po here in this section, since we have Sir Joe who manifested. So, sige po. Tinuro na.
Just a question. What AI agent or an entryway that is free or where we can test AI for our for biodiversity or our data sets? Or like, do you recommend Gemini, ChatGPT, or like just the entryway? Because we know most of the AI models has high paywall, but yeah, this is the question that we can like test for ourselves. Like, yeah, if ever open source or like have a free trial, like 14 days like that. So I think for us to really try on how AI works, or especially for those that doesn't haven't yet tested it out.
Great. Okay, thank you for that wonderful question. I actually think that's also very relevant, especially for people who are not as well versed into AI. So normally you would use programming languages, right? So like Python, for example. But then if you really just want to start off with understanding the data and then looking at what can you do with the data, you can always, of course, explore with either ChatGPT or Claude is good, and then it will give you like potential next steps. So like how could you understand this data better? What steps can you use? And then it can recommend like different ways forward, because it also depends what kind of questions do you want to answer. So for example, if you want to use agent if you want to do agent based modeling, you're probably going to do use GAMS, for example. Or if you want to do data forecasting, you're probably going to do you're probably going to use some other thing. So it really depends, but I think LLMs right now are pretty good at like trying to help you understand also where the next step is depending on the kind of research question that you have. So yeah, sir.
So while we're doing the workshop, I signed up in Sites. I got my API key. I asked Google AI Studio to make me an app to access the sites, and he asked me for my API key, and we were able to use it now. I'm not coding, I'm just prompting him. And then my group mates were interested with breeding, financial volume of transaction. Of course, heat maps were in the Philippines. So I have here El Nido, Agusan, Davao, Go, where we can check if the incidence report matches the financial volume of transaction. And even one of our group mates even asked, how about breeding? You know, any information about sites where breeding is being the activity that's being done. And you can see the difference. In Agusan, the breeding incidence is higher, although the incidence report and financial transactions are lower. So guys, just go Google AI Studio, use your email, just ask the AI to do the thing. So now I have tracking, live pa yan.
Yes.
So in answer to the question.
Yeah. Thank you so much, Sir Arian. I think the challenge here is that the CITES database is international. So this AI might be using data which is not necessarily from the CITES database. So it might be pulling data from other sources. And this is also why I think it's good if we going back to the recommendations, it's great that we have that, but it's good to verify as well, because CITES is a global database between countries. So going as little as how do you say it, as granular as provinces, and also CITES does not have financial information, so that's why it might be challenging. Yeah, that's why it might be pulling from some other data sources, which is great to look at. So again, it gives you a lead on which ones to look at, but then you still require experts, statisticians, econometrians, and also computer scientists with specific expertise into the method in order to actually make sure that we can support what AI has given us. But thank you, sir. That's really, really useful, especially if we can put all this data together and where it gets the data. That's really great. Thank you, sir. Sir is also from ICS. So we have full ICS support this afternoon. Okay, so I think we're good. Just next steps, because we are out of time. I'm so sorry for everyone. I'm taking 5 minutes of your time. I hope that's okay. We have snacks for the on in-person participants. So next steps, please. Um, up. Okay. Next steps, Dara, or do you want to do this or me?
All right. So let me just read all for the next steps for this afternoon. So, for both our in person and online participants, you can access and fill in the feedback form after our workshop. So, this is bit.ly BSP submission form. Sir Iram will also be flashing the QR code for your convenience. So, please make sure to input your workshop activity report. So, only the individuals that will be successfully submitting their accomplished activity forms in the submission and feedback form bin would be receiving their individual certificates for our session on AI for biodiversity. So again, this not only applies to our in-person participants, but also to our online participants via Zoom. So you can access the workshop activity sheet here that you have to accomplish and then submit that in the activity submission and feedback form to officially get your individual certificates for this afternoon. Ayan. So bigyan po namin kayo ng time to take a photo of the QR code. So the deadline po for submitting the activity form will be by tomorrow. So addressing the question of our sorry. Yes, there is an attachment needed which is this one, the workshop activity sheet. Okay, so we have to document um the activity that we did this afternoon and then submit that later on in the submission and feedback form. Okay? So, did we successfully get photos of the QRs? Ayan. So, I think we have been taking photos na po of already of these. So, I think if I may ask, Sir Iram, will we be posting the QRs or will it be exclusive here? Okay. So, we got a confirmation that if you weren't able to get the links or the QR codes, it will be posted publicly on the Facebook page of the Institute of Computer Science. So again, the deadline for submitting is by tomorrow. Is there a specific time, attorney? Oh, midnight. So medyo estudyante. So 8:59 pwede po tayo mag-submit. So mga 12, hindi na po yan accepted. Okay? Ayan. So, alright. So let's have a show of hearts. Kanina medyo likes yung pinapagawa ni Sir Attorney. So let's have a show of heart reactions to show our appreciation to Sir Attorney Chad's presentation for today, as well as a big round of applause for his presentation. So again, this is AI for Biodiversity Exploring the Global Wildlife Trade Database, a Balik Scientist 2026 workshop activity co-organized by ICS, SESAM, and UPLB Ovicre. So before we leave this hall, EAAL hall, let us have a quick photo opportunity here in front together with Attorney Chad Osorio. But before anything else, before we start the photo opportunity, may I call on the presence of ICS Director, Prof. Rachel Rojas, for the presentation of the Certificate of Appreciation to Attorney Osorio. Let me read the citation. So this certificate of appreciation is awarded to Chad Patrick Osorio in grateful recognition of his valuable contribution as speaker during the workshop entitled AI for Biodiversity Exploring the Global Wildlife Trade Database held on 16th of June 2026 at the Eliezer A. Albacea Lecture Hall, Institute of Computer Science, University of the Philippines, Los Baños College, Laguna. Signed by Sir Reginald Neil Ricario, CITED Head, and Prof. Rachel Rojas, Director of ICS. Congratulations po, Attorney Osorio, for us as well, actively in our sessions. We extend our gratitude to our online participants. So, if I may ask, let us all come in front po to have a quick photo opportunity with Attorney Chad. Thank you so much. Again, let's proceed here in front for a quick photo opportunity with our esteemed speaker. Maraming salamat. Thank you so much for your time in attending AI for Biodiversity. Please, as you leave the Eliezer A. Albacea Hall, you may get your snacks from the table outside of this room. Again, for participating in the AI for Biodiversity, snacks and drinks for everyone in this outside the Eliezer A. Albacea Hall. Thank you very much.
Ay, hindi pa patay.